So we have seen instrumentation, IR spectrophotometer. In that we have seen the source of radiations, monochromators. Okay. Now after monochromators, we have to see the handling of samples or sample cells. Okay. Now for IR spectroscopy, we require some treatment for the sample. We require to prepare the sample which should be ready for the scanning IR spectra. Okay. So my voice is clear to all?
Yes,
आवाज
sir.
येतोय का?
Yes, yes.
Okay.
Yes,
So that is called sampling technique. That is called sampling technique. Some treatment should be given for the sample. We may call the sample preparation for IR spectroscopy to scan the IR spectra. Okay, that is called handling of sample. Now this sampling technique is different for different states of sample. For gases, the sampling technique is different. For liquids, it is different. For solid, it is different. So to handle the different samples, which technique is used, that we have to see now. Now just like the UV visible spectroscopy or any other, there should be some space in the instrument to put the sample. Now we cannot put directly sample in that instrument. We require some container that we call it as a sample holder. In UV visible spectroscopy, that sample holder was a simple glass tubes, color corrected fused glass for UV, sorry, for a visible, and a quartz tube for UV. We have seen that the covet of colorimeter last year. आपण colorimeter ची ट्यूब बघितली UV visible मध्ये वापरण्यासाठी. Okay. Now in IR spectroscopy, the material which is used for holding the sample, that should be transparent to IR radiations. Okay. Now firstly we will see how the gas sample in a gaseous state is handled. In IR spectroscopy, we handle all states of samples, gaseous samples, liquid samples, as well as solid samples. Okay. For gaseous samples, one gas cell, that container used to fill the gas, that is called as gas cell. Such type of gas cell is used. This one. This infrared transparent window, it has a infrared transparent window allows the cell to be mounted directly. Okay. Then it has internal mirrors. The gas is put in this cell and it has internal mirrors. Now mirrors for what? To reflect the IR radiations many times. We know the gas molecule density of molecules is very less in gases. गॅसियस स्टेटमध्ये काय असतात? मॉलिक्युल्स खूप दूर दूर असतात. जर रेडिएशन त्या मॉलिक्यूल वरती स्ट्राईक झाले तरच ऍब्झॉर्प्शन होईल, नाहीतर ऍब्झॉर्प्शन होणार नाही. सिंगल पास केले, हे ट्यूब खूप छोटी असते, अबाउट 1 centimeter in length. This tube is very small. So if radiation passes one time through this tube, then the possibility of striking the radiations to the molecule is very less. So because of this, mirrors were placed in this one like this, at this position, at this position. So the IR radiations can reflect from this plate to this mirror to this mirror and many times. So what happens? The path length of radiation increases. ह्याच्याने काय होते? रेडिएशन्स जास्त वेळ ह्या सेलमध्ये राहतील आणि त्याच्यामुळं ते स्ट्राईक होण्याची जी कॅपॅसिटी आहे, स्ट्राईक होण्याची जी पॉसिबिलिटी आहे, ती पॉसिबिलिटी वाढेल. ओके. So it has internal mirrors. In vapor phase, rotational changes in molecule occurs freely. In gaseous state, molecules are free. They rotate freely. They rotate freely. Molecules are, the intermolecular forces are very, very less. So they rotate freely. Okay. And these low frequency processes can modulate the higher energy vibrational bands. This can affect the vibrational bands. In IR spectra, we are interested in vibrational band. We are interested in vibrational energy levels. In molecule, there is changes in vibrational energy levels. But in gaseous state, as these molecules are free, they can freely rotate around themselves. Okay. For this, rotational changes also taking place when we use a gaseous sample. Okay. So in gaseous, to handle the gaseous sample, such type of cell is used. It is called as gas cell. It has two IR transparent windows. Mostly these are made up of alkali halides. These two windows are made up of alkali halides, KBr or NaCl or NaBr or potassium, cesium bromide, etc., etc., which are transparent to IR radiations, which do not absorb IR radiations. Okay, so this is the sampling of gases, how gases are handled. Now, if the sample is liquid, then a thin film is squeezed between two infrared transparent windows like NaCl flats. What happens when we prepare the sample of liquids? Then two NaCl pellets were taken. One is this, another is above this one, and in between these two plates there is a thin layer of sample is made. A thin layer of sample is made in between these two plates. जसं आपण ओल्या सरफेस वरती काहीतरी ठेवलं किंवा पाणी टाकून, तुम्ही धरून बघा, पाणी टाकून त्याच्यावरती दुसरी एखादी प्लेट ठेवा, तर पाण्याची थिन लेअर तयार होते दोन्हीच्या मध्ये. तशा पद्धतीनं इन दिस वे अ थिन लेअर or thin film is squeezed between two infrared transparent windows. That is called, windows means plates. These are only pellets of NaCl or KBr which are transparent to IR radiation. So the salt plates or rock salts flat must be optically polished and cleaned immediately after use. Toluene, chloroform, etc. is used to clean them, and they should be dry and handled only by their edges. They should be handled only by their edges. Such type of material, such type of instrument is used to form a thin layer in between these. This is one, this is one, and this is pressed. Okay. The thickness of film can be adjusted by varying pressure used to squeeze the flats together. The thickness of that liquid membrane should be zero point 0.01 to zero point 0.1 millimeter. Thickness of that liquid membrane should be 0.01 to zero point 0.1 millimeter. So this can be adjusted by applying pressure. This can be applied adjust by applying pressure on both pallets. Okay. Now it consists of two windows of pressed salt sealed with separated sealed and separated by thin gaskets of Teflon. त्याच्यावरती मग टेफ्लॉन लावून टाकतील, कॉपर किंवा लेड दॅट हॅव बीन वेटेड विथ मर्क्युरी. ओके. मग त्या दोन प्लेटला त्याचं प्रेशर कमी होऊ नये म्हणून, त्याचं प्रेशर कमी होऊ नये म्हणून आपण दोन प्लेटला अशा दोन प्लेट ठेवल्या, त्याला साईडनं असं लॉक करून टाकायचं. So this can be done by using a thin gaskets of Teflon, copper or lead. Okay, and the windows, that plates which we are using, that plates are generally made up of sodium chloride, potassium bromide or cesium bromide. Okay. Now there are two cells. First cell containing sample, that depending upon the instrument. If the instrument is a double beam instrument, then we have to make two cells. First cell containing sample and second one containing pure solvent. Pure solvent सुद्धा असंच आपल्याला बनवावं लागेल. By the reference beam, solvent absorptions are cancelled out and the spectrum recorded is that of solute alone. So this is regarding sampling of liquids, how liquids are handled. A thin film is made in between two pellets of NaCl or KBr, and that is used to scan the IR spectra. The thickness of these plates should be in film should be 0.01 to zero point 0.1 millimeter. So this is regarding the sampling of gases and liquids. Now Sampling of solids. If the sample is solids, then how it is prepared? First one we call it as KBR disk. Generally, this is widely used as KBR is transparent to IR radiations. KBR is transparent to IR radiations. So generally, the tablets, small tablet-like uh, tablets are made. That sample is ground with KBR, potassium bromide सोबत थोडंसं सॅम्पल टाकून ग्राउंड करतात. फाईनली त्याला पावडर करायचं अँड अ टॅबलेट इज मेड जस्ट लाईक आपली पॅरासिटामॉलची टॅबलेट असते तशी टॅबलेट बनवतात. सो इट इज प्रिपेअर्ड बाय ग्राइंडिंग सॅम्पल विथ KBR and compressing the whole into a transparent water or disk. It is converted into a transparent disk. Then KBR must be dry. When we use KBR for this sampling, that KBR must be dry. If not, we know water absorbs infrared radiation. Okay. So the grinding is carried out under infrared lamp to avoid condensation of atmospheric moisture, which gives rise to broad absorption. Water त्याच्यामध्ये गेलं, then we get the broad bands for the absorption of water OH. Grinding is done in a aged mortar pestle. Mortar pestle मध्ये आपण grinding करतो. Now the particle size should be very small. That the particle size, when we ground this, the particle size should be very small. If particle sizes are larger, then there may be scattering of infrared radiation instead of transmitting. Instead of transmitting, there is a scattering of radiations. To scan infrared spectra, that the sample radiations must be transmitted. If we use such type of particles, then infrared radiations fall this and they scatter in different direction. Okay, so we won't need this scattering, we need transmission. These radiations should be transmitted through this sample like this, and some radiations will get absorbed here and remaining were transmitted as it is. So the particle size, when we ground the sample with KBR, that particle size should be smaller one. Generally this particle size should be 2 micrometer. The diameter of that particle should be 2 micrometer. Okay, then when we make such powder, then that powder is pressed by this instrument. It is called hydraulic press. It is called hydraulic press. That powder is placed here, and this whole dye is placed here, and a pressure is applied. A pressure is applied up to 10 tons of pressure. प्रेशर किती अप्लाय करावं लागेल? 10 टन. हे जे लिव्हर आहे, त्या लिव्हरला प्रेस केलं की हे खाली येते, प्रेशर अप्लाय होतं त्याच्यामध्ये. ओके, आणि हे प्रेशर गेज आहे, हे जे दिसायला तुम्हाला मीटर, दॅट इज अ प्रेशर गेज. ह्याच्यावरती किती प्रेशर आलं पाहिजे? 10 टन्स. एवढं आपल्याला प्रेस करावं लागेल. एवढं प्रेस केल्याच्या नंतर मग जे पावडर फिल केलं होतं आपण, that powder converts into tablets like this. These are the tablets prepared by KBR. Okay, the compression of a cohesive disc required high pressure. We see. Okay, special dyes are used. This is a dye. Such type of dyes are used to compress the air evacuated by hydraulic compression. Here hydraulic compression. The disc thus formed are easy to handle. Now these are hard. ह्याच्यावरती आपण 10 टनाचं प्रेशर टाकल्याच्या नंतर ते पावडर एकदम कम्पॅक्ट बनते, हार्ड बनते, जस्ट लाईक टॅबलेट. अँड दीज आर नाउ इझी टू हँडल. लिक्विड सॅम्पल मध्ये काय होतं? KBR पॅलेट घेतल्या होत्या दोन, आपण दोन्हीच्या मध्ये थिन लेअर बनवली होती. These are brittle. KBR pallet is a brittle one, so they are somewhat difficult. They should be handled carefully. The handling of such material is difficult, but here we are making a tablet. This is easy to handle. Okay, so in this way we prepare the sample for, if it is solid, for to scan the IR spectra. It is called KBR disk method. It is KBR disk method for the sampling of solids. Another one is a mulch. Mulch means pest. Pest. That the KBR pellets are harder one. KBR pellets are harder one. Okay. Now these pests prepared by grinding the sample with a drop of oil. सॅम्पल मध्ये एक ड्रॉप ऑइल टाकायचा आणि त्याचं पेस्ट बनवायचं लाईक टूथपेस्ट. पेस्ट आर सेमी सॉलिड्स, दीज आर सॉफ्ट. Okay. Then that mull is squeezed between transparent windows for liquid samples. Now the mulling agent should be ideally infrared transparent. जे ऑइल वापरायलो आपण मलिंग एजंट, ऑइल जे वापरायलो मलिंग एजंट, दॅट शुड बी इन्फ्रारेड ट्रान्सपरंट, बट दिस इज नॉट ट्रू. हे ऑइल इन्फ्रारेड ट्रान्सपरंट कधीच नसते. जनरली लिक्विड पॅराफिन नुजॉल is used to prepare nuzol mulch, which is transparent over a wide range in IR spectrum. वाईड रेंज मध्ये ट्रान्सपरंट आहे, पण फिंगरप्रिंट रिजन मध्ये ह्या न्यूजॉल साठी सुद्धा आपल्याला बँड्स मिळतील. न्यूजॉल इज अ लिक्विड पॅराफिन, इट इज अ लॉंग चेन हायड्रोकार्बन. इट इज अ लॉंग चेन हायड्रोकार्बन्स. So we get CH stretching, CH ring, C stretching, C ending, etc. for this nuzol also. Simply this technique is same just like liquids, but the difference is that while sampling the liquid, we are preparing thin layer of liquids, liquid sample, pure liquid that should be. But in here mull technique आपल्याला काय करायचंय, पेस्ट लाईक जसं आपण पिठाचा गोळा करतो चपात्या करण्यासाठी किंवा पोळ्या करण्यासाठी, तसं सॅम्पल मध्ये थोडंसं ऑइल टाकून सेमी सॉलिड पेस्ट करून घ्यायचं त्याला, आणि ते पेस्ट सेम 2 KBR पॅलेट मध्ये ठेवून द्यायचा. 2 KBR पॅलेट मध्ये तो पेस्ट ठेवून द्यायचा. असं जस्ट हिअर इट इज शोन हिअर. These are the NaCl pellets. In between two these NaCl pellets, that mull we have prepared, that should be applied in between these two, and it is pressed gently. याला आपण मग थोडंसं प्रेस करायचं. This layer is quite thicker. This layer is thicker than the liquid samples. Liquid sample पेक्षा ही लेअर कशी असेल, थिक असेल. Okay, this layer is thicker than the liquid sample. Now the nuzol paraffin which we are going to use, that also shows the absorption, and those bands should be subtracted from the sample. Another one is the solid films. Now solid films can be deposited onto NaCl plates by allowing a solution in a volatile solvent to evaporate drop by drop on the surface of the flat. Now in this, what we have to do, we have to take one NaCl pellet or KBR pellet, what we have to use. Just like when we put color varnishes to the material, then originally it was a liquid. What is it? It is a solution of that dye in some volatile solvent. ते आपण ब्रशनं मारल्यानंतर काय होते, सॉल्व्हंट इव्हापरेट होऊन जाते आणि ती सॉलिड लेअर तयार होते त्याच्यावरती. सेम वे सॉलिड कंपाऊंडची त्या एखाद्या व्होलाटाईल सॉल्व्हंट मध्ये सोल्युशन करायचं. सोल्युशन इज मेड इन अ व्होलाटाईल सॉल्व्हंट and that is applied on the surface of this NaCl. The solvent evaporates and a thin layer of solid sample is made on this NaCl plate. Then another one plate is put on that layer, and that should be placed in a instrument. Okay, so this is the third type of sampling of solids. Generally polymers and various waxy or fatty materials are used to are prepared by these solid films. वॅक्सी मटेरियल किंवा पॉलिमर्स जे आहेत त्यांचं आपण असं सॉलिड फिल्म बनवतो जनरली. most widely used technique of sampling is KBR palette if it is solid. सॉलिड जर सॅम्पल असेल तर वाईडली केबीआर पॅलेट्स वापरतो आपण. नुजालमल सुद्धा वापरत नाही, बिकॉज नुजालमल ॲब्झॉर्ब्स आयआर रेडिएशन्स अँड द स्पेक्ट्रा बिकम समवॉट कॉम्प्लिकेटेड. If in some cases KBR palette method is not possible, then we go to the Nujal method. And if Nujal method is also not possible, then we go to solid films. Okay. So these are the methods of sampling, handling of samples for the IR spectroscopy. IR स्पेक्ट्रामध्ये आपण सॅम्पल अशा पद्धतीनं हँडल करतो. गॅसेस असेल तर गॅस सेल, लिक्विड असेल तर 2 केबीआर पॅलेटच्या मध्ये 3 लेअर बनवायची, सॉलिड असेल तर 3 मेथड्स आहेत, केबीआर पॅलेट, नुजॉल्मल अँड सॉलिड फिल्म्स. Okay. So the questions in exam may be asked, if it is descriptive exam, then the sampling technique in IR spectroscopy. Okay. Now we have seen instrumentation, we have seen the uh, source of radiations, monochromators, samples. Now when the radiations passes through the sample, then the transmitted radiation should be analyzed. Then and then only we see which type of radiations and how up to what intensity these radiations are absorbed. These radiations are absorbed. That we have to study. So we have to analyze those transmitted radiations, and to analyze this, that is called as detector, the device which detects the transmitted radiations, that is called detector. So in a IR spectroscopy, spectroscopy, generally thermal conductivity detectors are used. Generally, or we may say the thermal detectors, because the energy of infrared radiation is less than the UV or visible. So the photocells we are used in UV visible spectrophotometer or photometers, that the works on the photoelectric effect. Electrons, when the radiation falls on that surface, then that surface emits electrons. Those electrons were collected by the another electrode and current is flown through the circuit, and that gives us the intensity of radiation, etc., etc. But the energy with infrared radiation is less. So the falling of infrared radiations on the metal surface do not cause ejection of electron. That do not cause ejection of electron. And if there is no ejection of electron, there is no flow of current through the circuit. So here we have to use some another detectors. So there are the first detector is called as thermocouple. Now, in any detector in IR spectrophotometer, that depends upon the two metal plates, or we may say the conductors. There are two conductors. In any type of detectors, there are two conductors. One is the reference conductor, and another one is the, we may say, the sample. So what was the technique? What is the principle that these two conductors were connected to a circuit? They are connected to a circuit, and in a absence of IR radiation, temperature of both conductors is same. They are made up of same material. They are made up of same material. As their temperature is same, the resistance of these conductors is also same. Okay, resistance is also same. But when this is reference is isolated from the radiation and higher radiations are allowed to fall on this sample plates, then the temperature of this one, due to IR radiations are hot. Because of this, the temperature of this plate increases, and because of increase in temperature, we know reference resistance decreases. टेम्परेचर इन्क्रीज झाल्यामुळे काय होते, रेजिस्टन्स डिक्रीज होते. आणि जेव्हा दोन्ही कंडक्टर मध्ये जे सेम करंट फ्लो होत होतं, ते आता ह्याचं रेजिस्टन्स कमी झाल्यामुळे ह्याच्यातून जास्त करंट फ्लो होईल. जेवढं जास्त टेम्परेचर वाढलं तेवढा जास्त रेजिस्टन्स कमी होईल. जेवढे जास्त रेडिएशन्स ह्या प्लेट्स वरती पडतील तेवढं जास्त ह्याचं टेम्परेचर वाढेल, तेवढा त्याचा रेजिस्टन्स कमी होईल, तेवढं जास्त त्यातून करंट फ्लो होईल. आणि अशा पद्धतीनं मग आपण रेडिएशन्स या डिटेक्टरनं डिटेक्ट करू शकतो. ओके. So the thermocouple, it consists of a pair of junction formed when two ends of metal such as bismuth, antimony. This is bismuth, bismuth. These two are same. It is connected with the antimony. Are fused in either ends of dissimilar metal wires. These are the metal wires. Heating capacity of absorbing element is small as to detect the change in temperature. Potential varies in the two junction with the difference in temperature. These are two junctions. The potential varies with difference in temperature. Okay. On one junction is cool junction, which is reference junction. दूसरं जंक्शन हे रेफरन्स जंक्शन होतं, that is cool. Okay. And kept at constant temperature. This is not exposed to IR radiation. This plate is not exposed to IR radiation. This is isolated one. The another junction is hot junction. Another junction is hot junction. This plate is hot junction. It is exposed to IR radiation. It is exposed to IR radiation. Okay. When IR radiation falls on that plate, then the temperature increases. Temperature increases, and because of this, the difference in temperature in two junctions, temperature of this junction and temperature of this junction becomes different now. Okay. The temperature difference due to falling IR radiations generate the potential difference, which amounts to IR radiation, which is proportional to the IR radiation. Okay. So in this way, there is current flow. We detect the IR radiations. So this is the thermocouple. These thermocouples are used as temperature sensors also in digital thermometers. In a digital thermometers, such thermocouples are used to sense the temperature. Another one is a bolometer. It is a type of resistance thermometer constructed from strips of metals such as platinum or nickel. There are two strips of metal, platinum or nickel, and these are they show a relatively large change in resistance as function of temperature. One plate is kept isolated, and another plate is exposed to IR radiation. एक plate IR radiation पासून दूर, cool, that is cool junction like in previous example, and in another plate, on another plate, IR radiations are allowed to form. They form arms of a Wheatstone bridge. Okay, they are formed arms of a Wheatstone bridge, and as change in resistance due to difference in temperature, there is as if IR radiation falls on the bridge become unbalanced due to change in the resistance. This causes current flow, which is measure of intensity of IR radiation. That current flow through the circuit is a measure of intensity of IR radiations. Okay, so this is the bolometer. This is the Goli cell detector. They are they are sensitive gas thermometer. They are sensitive gas thermometer. It is made up of this one. This is a diaphragm. This is a diaphragm which is flexible. Bottom of this tube is a flexible one. Okay, and this is filled with a xenon gas. It is filled with a xenon gas. Now, when radiation falls in this one, radiation enters in this tube, then what happens? The temperature of xenon gas increases. Temperature of xenon gas increases. Okay. Now, because of increase in temperature, volume of xenon gas increases. As this end is flexible, it can uh, uh, it can change in this direction, and the internal volume changes, and the internal volume is changing one. Okay. Now when the IR radiations reflect from this surface. If it is flat, then the angle of reflection is different. If it is curved, then the angle of refraction is different. So one phototube is placed here, which can collect this. The reflected radiations are allowed to pass fall on this plate. Okay. Now when IR radiations are blackened membrane, it is heated, which in turn heats xenon gas by conduction. Okay. The resulting in increase in pressure causes distortion of silver diaphragm in this way. As a result, the fraction of reflected light which strike the active surface of phototube, हे रिफ्लेक्टेड लाईट जी ऍक्टिव्ह सर्फेस हा फोटोट्यूबचा आहे ह्याच्यावरती पडत होती, ओके, इज चेंज लिडिंग टू चेंज इन फोटो करंट. दिस इज रिलेटेड टू द फॉलिंग IR रेडिएशन. हे फोटो करंट मग फ्लो व्हायला वेगळं फ्लो होईल आणि मग ते IR रेडिएशन्स डिटेक्ट करेल. ओके. There are some pyroelectric detectors also. They are constructed from single crystalline water of pyroelectric materials. Then photoconducting detectors are also there. So this is regarding the detectors which we are going to use in IR spectrophotometer. Okay. Now remaining the applications and the single beam and double beam instrument that we will see later on.